Hey guys, welcome back to the shop. I have a load of steel here that just landed in the shop floor that we've got to get into the Flex CNC and get a bunch of holes drilled and tapped in it. This is the job that I've been gearing up for right here. I've got our programs ready to go for this, for the Flex. I just created some drawings today as well, and I'm ready to get started on it. So let me show you what we're working with here. So this is A36 carbon steel plate, just commonly known as a hot rolled steel plate there, just a mild steel. You got two of these plates here. These are going to be considered the top plates. That's your dimensions 15 by 47. And then you got these bottom plates here, 27 by 59. So the top plates here are going to have the 2-inch holes drilled and tapped in both ends. So you got 4 holes per plate. We're going to put this in the Flex, put the holes in them, and then we're going to take these to the home shop and use the Flexarm to power tap those. These bottom plates here has got 16 holes, 5/8 holes drilled and tapped in those. Okay, so we got 32 total for the bottom plate, and it looks like we've got quite a bit of cleanup to do on them. We have, I can feel some slag on the bottom edge there from the burnout table. So we definitely, yeah, I can feel some underneath that. So I have a lot of cleanup to do first on these plates before I can actually get them into the machine. So this is going to take a little time. I'm just going to go ahead and knock all this out, get all this organized and cleaned up and ready to go. I'm not going to bore you with the details on that, just grind work and cleaning and getting it all prepped and ready. We're going to put the larger plates in this area right here. I'll have a couple of large parallels that I can set down onto the table, and we'll probably just use 4 toe clamps and clamp it down. And I don't know if I'm going to have enough room to put like a stop or a fence on here and equalize where the plate sits. So the larger plates, since there's only 2 of them, we may just clamp them down in place, get it trammed in on one side, and then find the edge. All I need to do is just find the X and Y on one corner and work off of that. These 2 vices here are going to hold the smaller plates. I need to take these jaws here. This is where we just did our test run. I need to bolt these to the outside of the vise. I've already got them trammed in. This one's ready to go. Just got to get that one to match. So this will be one workstation, and this will be the second workstation. All right, and then I've got a couple drawings here that I made up today. Been continuing my Fusion 360 training with Kevin over Mechanical Advantage. So he's been giving me a hand every week on some of these projects that I have coming up, and he gave me a hand with some of these drawings here as well. I have the top plate and the bottom plate, and I have only dimensions on here that I need to focus on, just the location of the holes. So nothing more and nothing less. Something that I can reference whenever we put the plates in there and make sure that the holes are in the right locations. All right, so I'm going to go ahead and start working on these guys, getting them cleaned up, and I'll bring you guys back when we're ready to start doing some machine loading and some machining. Well, we've got our first two plates cleaned up nicely. I pulled out Dad's old Wildcat, cleaned the top of it off, got a nice smooth surface, and I was getting rid of all the slag that the steel supply company leave on there and leave for me to clean up. We got it all cleaned up nice now, and this guy is ready to go. I got to go ahead and get our work location here set, and we're going to be using this back corner right here. So this is our 0 point, our origin point, should I say. Learning that in Fusion 360, origin points. So we'll X0 here, Y0 here, and then it'll put all the holes where it needs to be according to my drawing in Fusion 360. Got a stop here set up so we can put our next plate right up against this stop. And I want to point out I am using my Mighty Bite Talon grip jaws on here, and I have these jaws actually flipped around. I'm using some heavy washers to pull them up. That way the Talon grip jaws here are pushing against the thicker part of the jaw out that way instead of the thinner section that it's sitting on there now. So I wanted to make sure that we get as much clamping power as we can. So I did that on all of our jaws. Got them flipped around just like that. So it's pushing against the wide shoulder on the jaws there. I ended up having to use some studs, some flange nut and washers on that one there. So we've got it torqued down nice. It looks like all the jaws are clamped in there, so they all of them should be holding good, and we're about ready to go on this one. So I think I'm going to focus on these two plates first. We got the other one cleaned up nicely as well. It's ready to go. And so we'll get these two done and get them knocked out, and then we will move on to our larger plates right here that have all of the 5/8 holes in there. So there's some of my larger parallels that I brought from the shop, and this will be the first time getting to use these big boys right here. I had bought these several years ago from my friend Jack Hoying up in Ohio, some stuff that he had found, and just waiting for the right opportunity to use them. So these are going to go well with the Flexarm. I'm sorry, the Flex CNC bed. Okay, we're going to use our Heimer 3D probe here to go ahead and get our X and Y located. All right, X tenths. Just using the hand pendant right here to do nice, slow, controlled movements over this. So in case you're not aware on these Heimers, you have 2 zeros, and you just move it gently until the 2 zeros line up. You have your larger hand, that'd be at 12 o'clock right there. All right, and then you have a smaller hand that's pointing down at 0. So that is directly in the center of that spindle line. So we found X. We're doing G54 right here, and all we have to do is just push the X, set X-axis work offset to current machine position. Yes. All right, so X is positioned there now. And we'll do the same thing for Y and then Z once we touch off the top. All right, let's back it off. And we're gonna just move it Y plus. All right, move it X plus down a little ways. And then Y back to us, Y negative. All right, and then once you got 1 revolution left, I usually push a tenths. All right, there's our Y0. All right, there we go. Let me just back this out so I don't mess it up. Other way. Z up. For my Z touch off there, I've been using the 4-inch tool setter from Edge. You can use the Heimer 3D sensor too, so you can push up on the ball. But I've got to recalibrate this because I don't have the right number on our gauge length here. Whenever I measured this, I have to take consideration the diameter of the ball, and I just haven't got to that yet. So I just feel more comfortable knowing that I'm kind of touching off on the surface there of the workpiece. So we're going to take this out and just go with that other method for our Z. All right, we're going to use our Tungaloy drill to get this touched off. Same concept, you just bring this down until you get that dial indicator lined up on 0, and that'll be exactly 4 inches there. Just trying to get it in the middle. All right, let's go on down with it. And we'll move the tenths. All right, there's our Z position right there. Okay, I've got our Z touched off there. I've subtracted the 4 inches from our value. So we should be good to go. Go ahead and get this guy out of here. Okay, so I've got the work offsets set for this workpiece here. This is our G54. And just as a reminder, this is one of the pieces that we had tested here. This is our 2-inch UNC tap size right there, which is 1.781. And there's going to be 2 of these on this side, and there'll be 2 more on the opposite end of the plate right there. All right. I'm going to do an air cut on this first. We're going to move our Z position up a couple of inches. I'm going to run an air cut just to verify our positions and making sure everything looks right. Probably not film that. I don't want to waste a bunch of video time on an air cut, but I'm going to verify that and everything looks good. I'll bring you guys back and we'll go ahead and start getting this part machined. I just finished making the air cut on the piece, and I'm glad that I did this because I had to make several edits. There was a few things that I didn't actually put into this machining program that I already had in the test program. It was just some things that I overlooked, like the plunge rate, and I didn't actually have the proper tool set in the workpiece. I had forgot to go back and actually select the right tool, which is the Tungaloy tool. So anyway, I had to make a few little changes there, and I was able to get it proven out. I've just run it twice because I had to make another tweak. I run it a second time. This looks like it's ready to go, minus having to take our tool offset. I'm sorry, our Z work position. I added 2 inches to that so that we can make our air cut up here. All right, and it looks good. So I do need to modify that, but I did want to show you. So our lapse time is 9 minutes and 14 seconds to do the entire job right here. Now it's gonna be a little bit more than that because now we've got a chamfer tool in there, and you got longer tool changes on the Flex versus other machines like the Miltronics right here. Okay, so when we start the program, it's just gonna add a few seconds getting that drill out and things like that. But I think we're ready to go. I feel pretty good about this. I'm just really, really nervous because I don't want to mess this piece up, because if I do, that means I own it and I'm going to have to buy another one. And I really don't want to have to buy another piece. So I'm trying to make sure that I'm doing everything right. That's the difference between a CNC machine and doing things on a manual mill like this right here, is that you're in there and you can actually verify where your positions are to make sure you're cutting in the right spot. With this, yes, I could do some things where I could come down and touch it, and make sure our hole locations are there, but I don't want to have to go through that whole process as well. I think it's going to be good where it's at. I have verified the program. I have measured it. We should be 8 inches center to center on our holes, and our program shows that, so it should be good. And visually, it looks like the holes are in the right location. So I think this guy is ready to move forward with. So I think from here, we're going to see some metal chips flying now. I believe I am ready to start seeing some chips being made on our part here, and I'm sure that you are too. So let's go ahead and get to it. In between each one of the machining cycles, I'm going to pause the program and clean the camera lens off so you guys can see it. Not much I can do about the coolant spray, especially with that drill. So we'll just clean it off each time. So order of operation. First one is going to be our drill there, punch a 1-inch hole through the plate. And then the second op is going to be a 2D contour, which is going to rough the hole to size. Then we will be doing a 2D adaptive, which is going to clean up those holes to size. And then we'll come in with a 1/2-inch chamfer mill to machine the chamfers on the top. And then that'll be the end of the program at that point. I'm going to start this off kind of slow, just making sure that our tool is where it needs to be. And then once I prove that, I'll go ahead and go it up to 100% feed and let it do its thing. There's one thing that I need to do before I let it continue. I need to go into my manual controls. I've got the coolant interrupt selected. I'm going to deselect that. We're going to go back into our main controller and we're going to continue on. All right, so I'm going to bring it down slow here just to make sure that I want to see if we're in the right spot. I think we are. I love those drills. One of my favorite things to watch. All right, so we're gonna just pause this here for a sec. I gotta jump back into manual mode. That way I can open the door and I will get the camera lens cleaned off. I wanna go ahead and verify our distance there and just make sure that that is correct before we move on. I'm just gonna reach up in here with my stair hook rule, hook that hole, and that is, I can tell that that's 8 inches. That's what I want. And then let me look at my drawing. From the edge to the center of the hole is going to be 2 1/4. And that looks like 2 1/4. I'm going to do the same down here on this end and check those as well. All right, I feel much better. They're on size. I mean, they're where they need to be, should I say, not on size. They're in the right location. All right, so we're going to jump back in here and hit cycle start. This is going to be our 5/8 roughing end mill. Everything's looking good. All right, we'll go into manual. Same thing, let's get the lens cleaned off and then we'll move on to the next op. This is our 3/4 inch 4 flute carbide end mill. I love that through tool coolant with that Heimer tool holder. So this is gonna clean it up. A little bit of chatter in the corner, making that transition move. I think there's something that I missed. On my test program, I did 2 passes. And I think on this program here, I forgot to select 2 passes. So I'm gonna go in there and check that after this part's done, and I'll correct that for the second plate. Just those two transition areas. All right. Yep, I think that's just something I overlooked. I had multiple passes on there, just so it'd make like 10 thousandths a pass, you know, 2 passes. And on our actual program, I must have forgot to do that. All right, let's get our camera cleaned off and then we'll finish our chamfers. Okay, on to the chamfer. What I'll do is once we're through with the chamfer, I'll just run this tool again through there and it'll clean that up. I did a measure and it's about 2 thousandths undersize. So got a little bit of deflection there. Well, let's just carry on because we're almost done. Go back into auto, hit cycle start. This is a 1/2 inch diameter chamfer mill. I'm gonna bring this down slow. Let it start slow just to be sure that everything's good with this particular setting. All right, that's looking good. Go back up to 100%. This is also a 2D contour that we're doing with using as chamfering. That's it. Should send you to Z and X home. And it didn't. I forgot I reposted this and I didn't save that, or I didn't change it on the actual program. So I will fix that also. Let me go back into manual. Everything's looking good. So now I'll send you down there manually out of the way so we can get in there and check these guys out. You know what I want to do before I do that? I'm going to go ahead and do a mid-program start and rerun that 4-flute end mill just to clean up that last couple thou out of that hole. Just going to clean it up. Basically a spring pass here. All right, that should be it. We're gonna just abort this right here. Do a reset. All right, now we're gonna go ahead and move down out of the way. I'll fix this for our next plate. I wanna get in here and do some measuring and see what size our holes are. Our visual inspection of the part looks good. Our holes look good. They look just like in our test piece. We did good on our chips there. Switching to the rough end mill was the way to go. We have very little bird nesting in there. Haystacks, if you will. Underneath there, yep. Not too bad at all. All right, I think we've got a finished part here. We'll go ahead and clean this off. I'm gonna go ahead and measure one of these holes again and see where we're at on our diameter. All right, I've made the correction on my program, what it was in the 2D contour. In my test, I had it selected at multiple finishes, 2 finishing passes, so just 2 passes around it with a 10,000 step over. Whenever I had built the program for this, I forgot to select that, so that's why I only made that 1 pass. But we went ahead and ran the cutter through there, as you saw, and let me see what it landed on now. With our 2 equal passes in there, I was landing just about dead nuts on our tap size. Right now we are at 1.782. Let's see what kind of tenth reading I can get here. 782. 782 and 2/10. So I don't know, about a half, 6 or 7 tenths maybe over what I had on the other, which is, that's not a big deal at all. I mean, that's still on tap size right there. I'm splitting hairs right here. All I'm doing is trying to perfect landing on the exact tap size. On a 2-inch UNC hole like that, being off a few thousandths one way or the other isn't gonna make or break that at all. So this plate is finished up. We'll go ahead and get this one out, get our second one in there, and get it finished up too. We got the vices cleaned off. We're ready to fly this second piece in there. Got it pretty well balanced too. Okay, our second workpiece is clamped in there. Good to go. I think since we already got some inside footage, I'll just get a little bit of the outside machining in here. I made a modification to the bottom of our program so that once it's finished, the gantry will go to X home down there. So we should be ready to run this guy. Yep, we want to save. That's that change that I just told you I made. And got my feed rate down. Go back up to 100% there. Do a tool change to tool number 3. That's our Tungalloy Drill Meister, 1 inch. All right, let's watch it from out here. Tell you what, let's get through the curtain here. I love that drill. I do have my optional stop going here, so we got to hit cycle start to continue. That noise you guys hear is the auger. All those drilling chips down there. Changing to tool number 1. That's going to be our 3/4 inch 4 flute, so that we can finish the holes out. And then this time it should take 2 finishing passes around it. That sounds better. Still a little chatter, but still good. I should have selected keep tool down. That's another one that I forgot about. So the tool is retracting and then coming back into the hole for the second pass. It's another selection and fusion. You just click a box that says keep tool down. So many little things that you just have to remember when you're doing this programming, and I'm slowly getting there, slowly learning. Sounds like some rain hitting the roof. All right, last hole there, and then we're going to swap over to our chamfer mill and get our chamfers machined. That move there is something that I could have fixed too. It's whenever you're running this machine and you got to do a tool change and the gantry's got to move anyway, it's really not that big of a deal if we're going to come across here and go from one corner to the other. It would be better to go right back to the same hole, but that was another thing that I overlooked in the programming, and something else that I'm continuing to try to remember as we're building these programs here. See if I got this right. I got it right. Another beautiful set of holes in our second workpiece there. We'll get this cleaned off and I'll go ahead and get a measurement on them and see if they're the same size, see if they're on size anyway. All right, let's get our measurement here and see where we ended up. Looks like 781, 1.781. Good deal. Let's check one down here, see where it's at. That one's slightly smaller, 780 and 5/10. So that one's this is a half thou smaller than that one. Just want to see what this one is. Same thing. 1.780 and a half, so you got a half a thousandths difference in the diameter of the holes there. Nothing wrong with that at all. This guy is finished up. The CNC machining anyway, we still got to run the tap through the holes. It's such a relief to see these holes in here and everything's on size and good to go. So next step for these guys, we're going to load them up in the truck. We'll take these to the house. Last step will be using our Flexarm and our 2-inch tap to tap the threads in there for our 2-inch UNC. And we'll go ahead and get on that and get that finished up. So for now, I'm going to go ahead and start on these guys. So this will probably be a separate video. You know, we'll have this as a video and then we'll have these guys as a separate video. So I'm just going to go ahead and start on working that now because it's starting to rain. We'll get the flex all cleaned up and I'm going to start working on our new work offset here for our larger plates, these guys here. We've made it back to the home shop with our big Flexarm right here. This is the GHM 60. It'll accept up to a 2-inch tap, which is what we're going to be putting in these two plates right here. So first thing I wanted to share with this is with the Flexarm, you use these magnets. We got a magnet and a spindle, and this is what you can use to actually square the head up to your work surface. And that's what we're doing right here. We're going to go ahead and pull this over here and go ahead and just mag it down. All right. And then you have a joint here. So you have a knuckle, you have a joint here, and then you have a pivoting joint on the back that you can loosen up. And so all you do is just mag it down to your work surface, and you get down here and look, and you can tell if it's square on that workpiece right there. So we've already squared it up on this one. Now, whenever we go to pull this off, and we're going to come over here and do this one on this side, I can tell that that's a little bit crooked. So we've got to rotate it to square it up to this plate. And that's just because my work table here is not 100% flat all the way across there. But it doesn't matter. As long as you take your Flexarm and square it up to your work surface there where you're going to be tapping, that means you're in line with the hole. So that's what's important there. So we're good because I got this one squared up perfectly on that plate, and then we're good to go now. So we'll go ahead and pull this magnet out, and we can go ahead and put our tap in here. So here's our tap that's going to be doing the heavy work today. This is a 2-inch UNC tap, so 4.5 threads per inch. This particular tap is made by OSG, and we know that it works really good. We've tapped several holes with this. This is probably one of the most fun taps that I have that we get to use. It's a lot of fun. All right, so we have our tap. Here's our 2-inch tap holder. This has got a built-in clutch, so you can actually run with the Flexarms with any of these tapping holders here. You can bottom these things out, and you got an internal clutch that slips to keep from breaking the tap. But we'll just go ahead and stick this down in there. You have a square in there that actually drives the shank of the tap. And then to remove it, you simply just push this little flange down, and then you can pull the cutters back out. All right, and then we take this one and put it into the Flexarm here. Just like that. We're ready to tap. Let's fire up the Flexarm. It's super easy. Just pull this guy out, and you have speed 1 and 2. We have to validate that. So I'm in the first gear. So we're in first gear, validation, hit start. So this right here is your RPM. So for our tapping cycle going down, we're at 30. And then if I reverse this, I got it set at 50. And to change that, this is all hydraulic driven. So you see you got these little knobs right here. So like there's your slowest speed, which is 10 RPM. It's a little too slow, so we're gonna 30, there we go. 50 for the reverse. That's it. Easy as that right there. For my cutting fluid, I'm gonna be running my CRC cutting oil. I absolutely love this stuff and highly recommend it. It's got the foaming action, so you can spray it all over your cutters. You can spray it onto your workpiece down in the hole, and it clings to it and stays there. Works really well. That should do it. Ready to tap a hole? Let's go for it. Should be good. There we go. Did a beautiful job. So there's our magnet. I'm going to make sure that we're squared up over here on this plate. All right. This one's a little bit tricky to get to, but it's on the back of it here. There it goes. I don't know if you saw that or not. I was able to kick it my way just a little bit. All right, that's good that way. There it is. All right, it's squared up nicely now. Ready to tap. Four down, four to go. That's super easy. We moved over here to the opposite side. First thing I need to do is go ahead and move this arm around because it's too close. You'll see what I'm talking about. Like as we come down the tap, you can see the articulation because it's too close to that pivot point. So really easy. All you gotta do is just loosen up this clamp, this split block right here. And then we'll pull this arm back. And it's just a matter of testing it to see where it needs to be. So we'll probably have to move it twice to get this outer plate. See that last hole here? We're gonna have to reposition that. But to get this hole right here, that's where it needs to be. So you just gotta make sure that this is tight. All right, and then I'm gonna make sure that this is squared up. Make sure that this is squared up just like we did on the other side there. Actually, it's already squared up. It's good. It's touching all the way around the magnet there. We're ready to tap. There we go. Abby wants to jump in here and give us a hand with some tapping. So you ready for it?
Yeah.
Let's go.
And I'm lost.
There you go. Yep.
Down,
Yeah, the bottom button is down, the upper button is up.
Are you ready?
I am ready. Like a pro. Keep going. Keep going.
Okay.
All right, I think that's good. You just got to let it back out. There you go.
I was trying to make it go faster than it needed to be.
Well, you're making that tap look easy. Let's see your handiwork here. Oh yeah.
Did I nail it?
You did nail it.
Okay, good.
You tapped it. All right, we've got her squared up to our work here good. Yep, we're ready to tap. All right, last hole. All right, that is all 8 holes now tapped, ready to go. We're gonna put that guy around there, just like so. Man, I think it turned out good. We absolutely love using our Flexarm. This makes tapping fun, and I know Abby can validate that because she absolutely loves using it too. She had fun tapping that hole over there. But this is ready to go. We're gonna get some of our degreaser and blow the cutting oil out of the holes, use some air and clean them off really good, and stack them up on the back of the truck, and we're gonna go drop these guys off at the welding shop because they're waiting on these so they can start building these cars. They got a lot of welding to do to fab these things together. But this job is DUN done. I hope you guys enjoyed. I love sharing this stuff with you. We love showing the big boy tapping like this. And we got to have fun with our Flex CNC, putting our holes in there, which worked out great. It's just a good job all together. I had fun doing this one. I hope you guys enjoyed watching, and we'll see you on the next project. I think only a wife can appreciate that, huh? All right, I think we're ready to load them up.